Greetings and welcome to a nostalgic math chat. Today we're rambling about the department's May 2023 paper 2. We are looking at question 8.2. It's giving similarity. Let's get into it. In the diagram, triangle RDS is drawn. A, B, and C are points on RD, RS, and DS respectively, such that AB is parallel to DS and RB to BS is 5 to 3. Okay, so if this so if this is 5k, 5 times some number k, then we know that this will be 3 times that number k. So if it's 5 times 2, then the other one will be 3 times 2. If it's 5 times a half, then the other one will be 3 times a half, and so on. Okay, so that's the relationship between RB and BS. We are then told DC is 20. Okay, so I'm just going to highlight that so that I don't think it's the whole of DS. So DC is 20 units long and CS is 12 units long. Okay, so this little bit is 12 units long. And interestingly, so let's just see, this is 5 times 4 and this other guy is 3 times 4. So SC and DC are in the same ratio as BS and BR. Okay, interesting. So that's just me exploring the lay of the land, seeing what we've got going on. Okay, so now we are asked to prove, giving reasons, that BC is parallel to RD. Okay, I'm not gonna lie, I don't know my similarity theorems all too well. So I am guessing that the fact that these two sides have a 3 to 5 relationship going on, and these also have a 3 to 5 relationship going on. I'm guessing that there's a theorem that says that because they are divided into the same proportion by this line BC, that must mean that BC is parallel to the other side of the triangle RD. I know the reverse of the theorem. I know that if you have a triangle and you have some line parallel to one side of the triangle, then these sides are going to have been split by the same proportion. So I'm guessing that it also goes in reverse. Let me double check that that is in fact true. So I will sing a song in the meantime as I try to look for information. Interesting. Okay. Proportion theorem. Okay, so proportion theorem says a line drawn parallel to one side of a triangle divides the other two sides of the triangle in the same proportion. Okay, that one we know. Now, let's see if it also goes in reverse. It does. Okay, so the converse is also true. If a line divides two sides of a triangle in the same proportion, then the line is indeed parallel to the third side. Okay, and what is the nice reason for that? I'm trying to find the way to, what is the official reason that you give for that one? Oh, line divides sides in prop. Okay, perfect. So as I suspected, okay, because 8.2.1. So we know that RB to BS is 5 to 3. So by showing that these two segments also exist in a 5 to 3 ratio or 3 to 5 ratio, whatever, then we're showing that this line has split both sides by the same ratio into the same ratio, and therefore it must be parallel to that side. Okay, to the other side that isn't getting split. So let's write that down in mathematics. Okay, so we know that CD to, the ratio of CD to CS is 20 to 12, which is 5 to 3. Okay, if we just divide both sides by 4. Okay. Ooh. Righty-doos, which is equal to the ratio between RB and BS. Okay, so therefore the line BC splits RS and SD into, by the same ratio, I guess, by the same ratio, 5 to 3. Right, which tells us that therefore BC must be parallel to RD. And the reason is line divides sides in prop. Gotta love these little abbreviations, right? Prop for in proportion, same proportion. Okay, lovely. Well, that was a learning moment for me. Definitely some knowledge I'm going to hold on to for dear life. No? Okay, so there's that proof, nice and cute. Okay, and let's just double check with the memo that we agree. 8.2. Yes, so they also talk about, okay, the line dividing. Oh, okay, cool. So we've proven that BC is parallel to RD. They asked us to prove that BC is parallel to AD. Okay, I don't think they would punish you if you were to stop here, honestly, because it's just pretty straightforward to deduce that if RD is a straight line, A lies on that line, therefore if BC is parallel to this whole line, then it's also parallel to that little segment over there. So that was the little bit I was missing. Okay, then for question 8.2.2, we are further told, okay, let me just rub out all this other stuff. Okay, except don't rub out the fact that we have just shown that these are parallel. Okay, so we are further told that RD is 48 units. Okay, so this whole side, okay, is 48 units long. So calculate, giving reasons, the value of the ratio AD to AB. Okay. Okay. So AD to AB. Okay. So what I'm inclined to do here is to say oh well, okay, so something that stands out for me is that these two lines are parallel. Okay, so we then know that because we have a line that's parallel to one of the sides of the triangle RDS, that means that this side has also been split into a 5:3 ratio, right? 5 times whatever will be, and then that other one will be 3m, whatever that number is. Okay, so that means we can split up the 48 in the ratio 5:3 so that we get this piece and this piece's length. Okay, and then to get the length of AB, this is over here, this is a parallelogram because we've got two pairs of opposite parallel sides. What? Okay, so ABCD is a parallelogram, so that means because that's 20, then that must also be 20. Okay, awesome. So we have a game plan. Okay, so the first part of the game plan is to say that the side RD has been split in the same ratio as the side RS by this line segment AB. So let's say that first. So we will say the ratio of RA to AD is the same as the ratio of RB to BS. Reason for that being line parallel to one side of triangle, right? So that means that the ratio of RA to AD is also 5:3. Okay, and that tells us that AD is 3/8 of RD. Okay, right? Because if it's split by a ratio 5:3, that means the one segment is 5/8 of this whole line, and the other segment is 3/8 of the whole line. Okay, so that is 3/8 of 48. Okay, and 3/8 of 48 is just 1/8 of 48 is 6, so 3 of them will be 18. Okay, so we've got AD, awesome, so we know that that is 18. Okay, so now to figure out AB, we say, okay, A, B, C, D, okay, I'm just going to say we're coming here, is a parallelogram. And why is that? It's because we have two pairs of parallel sides. Okay, so that means we can now apply the properties of a parallelogram. So therefore AB is equal to CD because opposite sides of a parallelogram are equal. So that means AB is equal to 20 units. Okay, so now we've got our AD. Ooh, okay, I want it to be a bit thicker. Okay, so AD is 18 units and AB is 20 units, so we can work out this ratio now. It is. So the ratio of AD to AB will be 18 to 20. Okay, highest common factor of 18 and 20 is 2. So we divide both sides by 2 and we get 9 to 10. Right, let us verify. We do indeed have 9 to 10 as our final answer. Perfecto.